Okay. Hello, everyone. Today we are going to talk about framework-independent applications with Swift. We are going to start with the motivation to do this kind of method, the trade-offs to apply it. Then we are going to see the structure of a typical application, and then we will end with a practical example. So the main motivation could be to write some applications that can run anywhere. We write our application once, and then we run it on the Mac, on the iPhone, etc. But that is not our main motivation here. Our main motivation is testability. Why? Because we want, if we design an application to be testable, we design it to have reusable components. We let the architectures emerge naturally, and we have more maintainable applications. The benefits of using these methods is that the code is easier to test. If it is easier to test, it's also easier to understand and to maintain. And we can also have an abstraction from the framework we are working. So it's more easy for a person that doesn't know the framework to contribute to the project. There are some costs to apply this. First is that we have to include a mindset change in the people that work in the project. Is a way of developing applications that a lot of people are not used to. And we have to train the people that started the project how we apply this kind of architecture. So the main idea is very simple. It's a very simple concept. Is that we divide what is dependent on the framework from what is independent of the framework, in a way that these two communicate is by using interfaces. So in Swift, interfaces are defined as protocols. And in the Swift community is more known this kind of method as protocol-oriented programming. The practical example that I will show is a login application. It's a very simple application that has some a practical use, and a lot of apps use it. The way that we design this application is to have, like we said before, all the things that depend on the framework. For example, the view that in iOS we can define with Xib or Storyboard or by code, and a view controller that controls this view. This is the framework-dependent part that depends, in this example, of YKit, but could be another kind of framework, for example, for the sensors, for the maps, etc. And we design our business logic, the things that interact with our application and have the logic to manage, to be independent of the framework. This kind of objects, the presenters, the service, are completely independent of YKit or of the foundation, every framework of the iOS. And the idea is to keep this line very well defined in a way that the parts that are dependent communicate only with the abstractions. These parts that are independent are, like we said, easy to test. They are easier to port and easier to maintain, since they don't attach any meaning to them. Now I will do a demo of this login application. The source code is available in the GitHub repository. So we'll see the application here is divided for all the parts that are independent of the framework. The parts that are dependent on the framework, in this case iOS. And in here we can see our unit test of the application. These tests define not how the iOS application works, but how our business logic should work. For example, that when the username is empty, we should show that the username is empty. but the way that is implemented in iOS can be totally different for how it is on the Mac or on the TV. I will run the application, and we can see that it misses some behavior. That is, when our application has wrong credentials, we see correctly an alert saying that the credentials are not valid, but we see that the loading interface keeps on spinning. So we miss a behavior in our application. That doesn't mean that we have to code it on directly on the framework. The typical flow that we do is first to write a test that defines the behavior. When for example, in this case, when the verifying credential ends, we hide the loading the interface. We create our objects that are, all these objects are from this part of the application, are independent and can be easily tested. For example, in here, we create a presenter that is responsible for managing the login. We tell it to do the login, and then we verify that on the view, someone notify it that he has to hide the loading interface. We typically make run this test. And it passes. Whoa. Interesting. It should not pass. This is a bug from. Let's try it again. Okay, Xcode.
Very slow. What kind of tests are these?
These are
UI tests.
Unit tests. Okay, and we see that the test failed. Our application still doesn't manage this like we saw before on the end-to-end test. Our application still doesn't manage this behavior. What we can do is to code it now. For example, on the interface that is a protocol, we say that the login view should also hide its loading interface. We make the test again, and now we have a compilation error that says that our view controller doesn't implement the interface. For now, I will make it only implement just to compile the code. The test still fails. And we go on the presenter that is responsible to encode this behavior. So I simply say that when I forgot the code snippet. Okay, presenter. Doesn't work there. Okay, I will write it. I will say that when in here we can see on the presenter how it is supposed to work. It is supposed that when someone calls login, I should call a service that validates the credentials. And in our case, what is missing is that when this verify ends, we should also not only show that the credentials are valid, but should also hide the loading interface on both cases, even if the credentials were successfully verified or not. And now we can see that our application now has the right behavior, and it passes. When the verified credentials ends, it hides the loading interface. But our application still doesn't do anything because this is the part responsible that is independent of the framework. So we have to implement it in iOS. In iOS, how we choose to do this is when the loading interface is to hide the button of login and show a spinner. And in here, it will be the opposite. If it is maybe like this view, that is to hide, to show the login button and to hide the spinner. We can see now if we run our application and we put some wrong credentials, it starts to spin, and then when the credentials are not valid, I can do again. This allows also, I'm using a fake API. Now I will say that a token is not empty, so the authentication is successful. Our application, when you do the login, shows the magic number of 42. This kind of way of developing the application is also very nice because in here we encoded all of our behavior of our app, doing unit tests that are very fast to run and give us a fast feedback loop in the way that our application should behave. If we see, they run in 14 microseconds. No, 14 milliseconds. 7 tests is 2 milliseconds, 2 milliseconds per test. They are very fast and can give us a feedback loop when we are developing. And then we can, for example, write a white test that validates the happy case. In this case, the case is that when we insert a username and a password and we click login, we see the label 42. You can see in here the functional UI test, and it passes like this. We can encode all of our behavior in here, doing fast unit tests, and do the main flows of our application that do the happy path in a simple UI test. Back to the presentation. The sample code is available here if you want to download it. And in here are some references that I used to prepare this presentation. The slides are available in this link. And that's all. Now I will take some questions.
Why do you think this approach isn't as widespread as it should be?
For me, one of the reasons is that it costs more first to learn, to know that it's possible to write an iOS application that doesn't depend on WiKit, it doesn't depend on the sensors of the phone. That is the first step. Second, is it inevitable creates more indirection on the application, because we are programming versus some abstractions instead of some concrete things, and this can create some confusion and leads to more slow time on the beginning of the development. Once you learn it, is very nice to use. And I should also add that it depends also on the application that you are doing. Because if it is a proof of concept, if it is something that is to throw away, this way of developing the application costs us more than to do a simple application that just does a simple design. That are the two main things.
What is the effort to move from legacy code to this kind of architecture?
A difficult question. So if you have a legacy code, what I would suggest to do is first to try to always think this code is dependent on the framework, or this code can be totally independent. and to start to extract little pieces of functionality and define it in a way that represent the standard behavior. In a way that can also, the abstraction can also call the legacy code, but wrap it around to be easy to test and so you can verify that you don't break anything. And from then on, all the new things that you develop with this new kind of mentality.
Okay.
Is it really possible to share modules between iOS, Apple TV, and macOS?
So between iOS, tvOS, and watchOS is very is more easy to share, since the foundations are more or less similar. Between macOS and iOS is already more difficult because the framework dependent sometimes are done just for iOS and not to macOS also. But if you develop in this kind of way, it's very easy to do an application that can run on, is the next step that I will want to port. I would like to port also this to macOS to see the difference between that. And that, with some effort, you can easily run in every Darwin platform.
Because you're basically working with different frameworks for every player here.
Mm-hmm.
So that was the question. Is it even possible to share models?
It is. One thing that is more difficult, but with Swift 3.0, that the main goal is portability, is to run, for example, this kind of code on a Linux machine. And in there, it will be more difficult because if you think a lot of things that we don't even see here, like dynamic dispatch, they depend on the foundations, the foundation framework from Objective-C. And you are not even aware that you are using this kind of frameworks when you are doing. It's not. We can say that is pure Swift code, but sometimes we are not even aware that that is not. So between Apple platform, you can do with some effort, but is fairly possible. Between other platforms, still it's very difficult.
Okay. Why in the example you start from the unit test and not from WATI?
Okay. I start from the unit test because it gives you a more fast feedback. And in this case, that it's not that I'm starting to develop this feature. When starting to develop the feature, makes sense to develop an end-to-end test that asserts that the login works. And while you are doing this kind of iterations with the unit tests, the end-to-end test always fails till you pass all the unit tests and then your feature is implemented. The flow is more like that. I started with the unit test because all the other behavior was already, the API case was already working. And all the other cases of failing were already encoded. So, but the typical flow is to write an end-to-end test where you assert that the feature that you are starting to work, that keeps on failing, and you go on the smaller feedback loop with the unit tests.
Okay.
You said we have a more indirection here. When we work with devices that have less power, less computing power, or resources in general, indirection can maybe be a downside if it comes to performance.
No, I say that is more. No, I don't think is because on the end you program versus abstractions, but when the code is executed, you are injecting concrete classes. For example, if you look in here on the code of the view controller, the view controller instantiates a presenter with a view that is a login view, that is our interface, and a login service, that is someone that responds to this method. But if you look at the objects are the login view controller and the service that is built with this factory is a Llama Fire login view controller that is a concrete class. So there is no hit in performance. When I say indirection, is more to understand in here the presenter which kind of service it's using in the iOS application. If you organize the code well, you can understand in here. I see that is a Llama Fire. It's a login service that uses the framework, this framework to do HTTP requests. But this can be confusing because if I'm looking at the code of the presenter, I don't know that. I have to go to the concrete classes and go all the way down. When I said indirection was in that sense.
Thanks.
Okay.
Yeah.
All right. Thank you.